we are still on topic split. So topic equals to geographic information systems, and then topic dot split split tab there. Any brackets? One space there. So the result is a list of the individual words in the string. Next, we can see how to apply the split method to work with path. So for example, we have a shapefile in C drive and data part 1 and final. How will we obtain the last part of the path? So what we will do is we will have a path equals C, and it's in data and part 1 and final, and path list equals path dot split. Oh no, split, and then with the slash, and last path equals path list and -1, and we're going to print last path, and it's final. So what happened exactly in the first line of code? The path is assigned as a string to the variable path. In the second line of code, the string is split into 4 strings, which are assigned to the list variable path list. And in the third line of code, the last string in the list with index -1 is assigned to the string variable last path. So, and we're going to do one more, run the following code, that we will have my list equals to, we have A, we have B, and we have C. My list append D and print my list, and we should have a B, C, D. So very few built-in methods are available for numbers, so in general we can use the built-in functions of Python or import the math mode to work with numerical variables. And we're going to use modules. So hundreds of additional functions are stored in modules. Before we can use a function, we're going to import its module using the import function. So the functions we used in the preceding sections are part of Python's built-in functions and don't need to be imported. One of the most modules to import is the math module. So we're going to start with that one. We're going to do import math, and enter, and we will have h equals math door floor, and we have 7.989, and we print h. Then we have a 7.0. Notice how the math module works. We're going to import a module using import and then use the functions from that module by writing module.function. Hence, we use math.floor. The math.floor function always rounds down. So it rounds down, and whereas the built-in round function rounds to the nearest integer, we can obtain a list of all the functions in the math module using the direction statement. So we're going to print die, and we have math there. So we can learn about each function in the Python manuals, but remember that you can also see syntax in the Python window help and the syntax panel. And we're going to do math floor. So now return the floor of x as a float. This is the largest integer value, smaller and greater than x. Another way to see the documentation is use the we can do is print math dot floor and dot doc 2. This time I remember to print 2 for underscore. So the underscore dot doc and the underscore statement directly in Python. So this one we did is print math dot floor dot underscore doc underscore. The result is a print out of the same syntax help, but now directly within the interactive Python interpreter. So the syntax is floor x, which means the only parameter of this function is a single value. The function returns a float such as 7.0, not an integer such as 7. This information allows you to determine whether the function is really what you are looking for and how to use it correctly. And remember that you need to add a prefix to any non-built-in functions using the name of the module as a math.floor x, not just floor x. If you do not use a prefix, you will get an error stating that the name floor is not defined. There are numerous modules available in the Python. A complete list can be found in the Python manuals, so which we're going to look a little bit. And we're going to access the help document on the taskbar, and then we're going to go to start button and then click, and hopefully I have it. I don't know for sure. Yeah, I do have it. So it's in my start, and you bring the Python manual up, and you have this. And then in the documentation table of contents, we're going to go to indices and tables. So indices and tables. Indices and tables. General index. Let's see, where is indices and tables? General index. Oh, global module index. All right. Global module index. So in the documentation under table of contents under indices and tables. So we had global module index, and then the index provides an alphabetic list of all the available modules. So there are many specialized modules, and in a typical Python script, we may use several. Try taking a look at just one more time. For example, scroll down to the random module. So it should be R. The random module is right here. So, random module, and then we click and the link and scroll down to the uniform function. Random, where did the uniform go? Right here. Uniform, where did the uniform go? This is interesting. Oh, on uniform. Yeah, right here. And then it says here, return a random floating point number n, such as a for a smaller and equals to n, and n smaller and equal to b, for a smaller and equal to b, and b smaller and equal to n, and n is smaller and equal to a, for b is smaller than a. Notice that the uniform function has two required parameters, a and b. We're going to try this function next in Python. We're going to close the documentation and return to the Python window. We do not, we can just minimize here. I can just put it here because I might need to look at it. Anyway, we're going to run the following code. So we're going to import random and j equals random dot uniform, and from to 100, and then print j. There. So the result is a float. It's a float from 100 to 0 to 100. And then we can print j again. Print j. It's already defined. All right, we can close ArcMap. And we're going to save the Python code as script next. And now we're going back to Python Wing. Okay, we have our new Python Wing here already. Right, so far we worked within the Python window interactive Python interpreter. This works great to practice writing Python code to run relatively simple code. However, once the code gets a little bit more complex, we will typically want to save the work to a Python script. So although we can save the code from the Python windows to a script file, we will first practice creating, writing, and saving scripts using the Python Wing editor. So now we have on the taskbar, we click Start button, and then on the Start menu, I cannot find Python 2.7 Python Wing. I click that. Maybe it's right here. I have to go back and find it again. Where is my A? Oh, right here. It's in Python 2.7. I don't have a 2.7. I don't have Python 2.7. Python, I do not have it. So, but I could just type in Python Wing and I bring Python Wing up. Notice by default, the Python Wing opens with an interactive window. That interactive window, which works very well, very much like the Python window in ArcMap. So next we're going to create a new script window. So then on the Python Wing, we're going to standard toolbar, and this one is new. And we can click on it, and we just click Python script and click OK. Using the new button in Python Wing is the same as using File New from the menu bar, or I can just go here and new. So, or you can do Control N. It's the same. And then we're going to rearrange the window so that both the interactive window and everything will be in the same window. And the interactive window and the new script window are visible at the same time. So, and next we're going to enter the same code we worked in the Python window. So in the script window, this is the script window. I'm going to put path. You don't see the prompt, but I'm going to type in, and then I have a C and data and part 1 and final. And then I have a path list equals to path dot split, and I have split it, and I have a last path equals path list, and -1 and print last path.